In this tutorial, I'm going to show you how to bring attributes from Houdini into Lens Studio and how to use them to drive transformations like scale. I'm also going to show you how to use the copy to point script within Lens Studio to emulate copy to points functionality from Houdini. The result will look something like this. Open up Houdini, then hit Tab and add a GeoNode on the object level. Then double-click to dive inside the GeoNode we just added and add a circle. Set the orientation of the circle to the ZX plane and set the primitive type to NURBS curve. Duplicate the circle, then add a sweep node. The second circle will act as the shape that is swept along the first circle. Plug the first circle into the first input and the second circle into the second input. Now hover and click the blue eye to view the operation. Now select the second circle and change the orientation to XY. Then middle mouse over the radius and slide until you achieve a shape that resembles a halo. This is going to serve as the geometry for our halo in the lens. We will now scatter points in a radius around this geometry. These points will be imported into Lens Studio, where we will copy sparkles to each point. These sparkles will scale based on the proximity to the user's hand. Add a poly extrude and set the distance such that it creates a mesh within which you would want the points for the sparkles to scatter. We will add an ISO offset in a bit, which will slightly increase this range. So bear that in mind. I ended up going with a value of -0.08. Now add an ISO offset below the poly extrude. This will turn our geometry into a volume. We want to set our uniform sampling to about 32. This increases the resolution of our volume. If we add a scatter node below the ISO offset, it will use the density of the volume to place points. We can change the number of points by changing the force total count parameter. I set mine to 120. Now the copy to points template, which I created for SnapLens, orients based on the normal and up attributes which are imported from Houdini. Let's add those attributes now. Start by creating a transform node and an attribute wrangle. Feed the scatter into the attribute wrangle's first input, and then the scatter into the transform, and then the transform into the attribute wrangle's second input. We are going to use the transformation of these points to create normals using just 2 lines of vex. Click on the attribute wrangle and enter the following code in the vexpression field. I will also paste the code into the video description to avoid typos. The first line of code creates an up attribute, which is the same for all points. It creates a vector 0, 1, 0. The first 0 is x, the 1 is y, and the 0 on the end is the z. Combined, they define a transformation away from the origin. In this case, they're creating an arrow that points straight up. The second line creates the normal attribute. This is the attribute that will tell objects copied to these points what direction they should look at. It creates this vector by subtracting the position of the original points from the position of the transformed points. Before continuing, make sure that you have the point normals button on the right side of the viewport checked. You won't see any normals at first because we haven't modified the transform yet. If I modify the transform, you'll see these blue lines showing up. These are point normals. I'll set the uniform scale of the transform to about 0.5. This will mean that any geometry copied to these points will be facing the center of the halo. Now let's create an attribute that controls the scale of objects copied to each point individually. This will allow us to randomize the points and have each object have a different scale. Add an attribute create node and name the attribute pscale. Now we are going to add an attribute randomize node, and we are going to select the pscale attribute. We're going to reduce the number of dimensions from 3 to 1 because we're not dealing with a vec3 attribute, and I'm going to leave the value range to between 0 and 1. Right-click the attribute randomize and select Spreadsheet. These are the attributes that we will be using in SnapLens. We have position, normal, and up, all of which are vec3s, and then we have p-scale. We are almost ready to bring over the attributes. There's only one issue. Currently, they're stored in the wrong order. The script is not set to recognize them by name, but by the order in which they appear. We need to rearrange them to be in the order of position, then up, then normal, and then p-scale. We can do this easily with an attribute rename. So, add an attribute rename below the attribute randomize. Houdini is set up so that position always shows up first in the graph. So let's just rearrange the other ones by putting them in alphabetical order. Type in the attribute's current name, and then type in the new name that you want to assign it. To keep it simple, I just put 3 A's before up, 2 before N, and 1 before p-scale. We still haven't seen an update in the spreadsheet, but that's because we're still looking at the spreadsheet for the node above the one we just added. So open the new spreadsheet, and you should see that your attributes are in the correct order. Now that our data is ready to transfer to Lens Studio, let's also export our geometry. Note that if you're using the Houdini Apprentice Edition, you might not be able to export in FBX. That said, if you just need geometry, you can probably just put together a torus in another program and it'll work quite well as a placeholder. To export in FBX, add a ROP FBX node and connect it to the sweep node. Select the folder that you want to save your file to, name your file, hit accept, and then click on Save to Disk. Now that our assets are ready to be brought over from Houdini, we're going to start by setting up the template. First, create a project folder that you're going to put all of your assets in. Go to the video description and download the Copy to Points template. Extract the contents and move them into the project folder. You can then delete the old zip file. Open the template folder and then open the Copy to Points template lens project. We are going to start by replacing the copy object, which is currently the sphere, with the sparkles that we'll be using with the halo. Let's download the sparkle asset from the link in the video description. While we are downloading assets, let's also download the glow asset. Once the assets are downloaded, open up the project folder and create an asset folder. Then drag both of these assets inside. Then drag the assets from the folder into Lens Studio's resource panel. The Copy to Points script will copy anything that is a child of the ctp_copy object empty object. So currently it's copying the mesh from the ctp mesh replace me. But we could technically put anything in there, not necessarily a mesh object. I'm going to add an image object now. We will replace the default image with the sparkle image by drag and dropping the sparkle texture into the texture slot of the image object. We will also make our image object camera facing. That way, all of the sparkles always face the camera. I will disable the sphere that came with the template so that it doesn't show up with the copies anymore. Then we will reduce the scale so that it isn't enormous. To get our lens to update our changes, we can hit the refresh icon. Next, we will bring in our geometry from Houdini. So find where you saved your Houdini geometry and bring it into your SnapLens project assets folder. Then drag the FBX into your Lens Studio resources folder. Towards the bottom of the camera hierarchy, you should find an empty object labeled Static Houdini Objects. Inside that, you see an object labeled Houdini Object Replace Me. that is a mesh object. Enable it. We will take the mesh from the FBX and put it into the Houdini object replace me. You will notice a purple and black noise. That is because we have not given it a material. So if we go into the resources panel and hit add material gold, then we can drag and drop that into the material. Next, we will input the points from Houdini into the copy to points manager at the top of our scene. The manager creates global variables that can be accessed from any script in the scene. To open the script, go to the resources panel and select the ctp_scripts folder, and you should see the LNT copy to points manager script. Double click it and the script panel will open. At the very top of the script, you can see all the points that are used in the template. The points here are formatted as arrays, which can be accessed through for loops. There is an easy way to convert our tables from Houdini into arrays like these. Go to the video description and open the Mr. Data Converters link. Set the output to JSON row arrays. Now go back to Houdini and copy your data from the attribute rename spreadsheet. Select one corner and then go and shift select the opposite corner. Now hit copy and paste it into the top field of Mr. Data Converter. Now copy the bottom field from Mr. Data Converter and paste it in place of the previous row arrays. Make sure you go from the very bottom bracket all the way to the one right after the equal sign. Then hit paste. You'll notice that the points haven't updated yet. That's because we need to update the script. Click in the blank area on the script and then hit Ctrl S. Once saved, your lens should automatically update and you should be able to see the sparkles surrounding your halo. Next, we need to set up our scaling attributes so that the sparkles respond the way we want them to in reaction to proximity of the user's hand. Start by opening the Scale by Attribute script. Inside, you'll see a max scale and min scale variable. Change the min scale variable to 0. Change the max scale variable to 2. Means that when the hand is out of range of the sparkle will be invisible. And when it is completely in range, it will be double the size of what it is by default. When the hand is not visible yet in frame, it defaults this position to measure against to the center of the frame. That is why the middle of these sparkles is bigger and they fall off towards the edges. If we transform the y-axis of the transform all empty object, then you'll see that the sparkles will shrink as the halo comes into place above the user's head. Notice how the halo overlaps incorrectly over the hair. This is fixable using an occlusion. So if we enable the face occlusion and adjust the y-axis, you'll see that it clips off. Using an occlusion object is by no means perfect and definitely won't fit everyone's head perfectly, but it's better than nothing. Reset the Y height and let's send the lens to the device to see how it's looking so far. If you haven't sent a lens to the device before, it will come up with a snap code which you can scan in Snapchat, and then your lens will show up on your device.
You'll see now if I raise my hand and trace it around the halo, the sparkles scale up based on the proximity with my hand. You will also notice that not every sparkle scales the same amount. This is because of the piece scale attribute that we created in Houdini that randomizes the scale within a certain range. This is just one of the many benefits of having the ability to move data between Houdini and SnapLens.
This is the essentials of how to use the copy to points script within SnapLens. I'll be uploading another tutorial on just polishing this lens. That will be up next. And then after that, I will be uploading a video that goes through the script that I wrote and kind of explains how it works on a bit of a deeper level and how to manipulate it for anyone who's interested in getting deeper into the scripting of it. I hope you found this tutorial useful.